to part 2 of our 3D printing workflow. So we have a closed poly surface that is ready for 3D printing. Almost. Whenever I modeled this, there was actually no particular size that I was modeling to. Well, we need to change that. All right, now for the project, we're saying that we want an object no bigger, if we can, than 2 inches by 3 inches by 4 inches. Okay, that's the general build area. So that brings about two issues. What units are we modeling in currently, and what size is this currently modeled at? So for the first, we are going to type in units. Okay, I model this in inches, and that's exactly what we want, either inches or millimeters, not feet. If this was feet, then we would want to change that from feet to inches. And then rescale the object. Okay, now that we're in inches, so issue 1 taken care of. We are in inches. How big is this currently? We're going to type in a command called bounding box. Set objects to frame with the box. Output curves. Okay, this gives us a box that encompasses the geometry, and currently that box is 7.5 inches by a little over 7 inches by a little over 7.5. Okay, so it's a little big. So what we're going to do next is I'm going to make a box that is 2 inches by 3 inches. Oops. By 3 inches by 4 inches. Okay. And what we're going to do. All right. So this now needs to fit inside of that. So I'm going to say scale. Say zoop. Actually, let's do this way. Okay. Now, the reason we want this particular size for our output is it's going to help us make it so that 3D prints don't take too long. There's an assumption. The assumption is that you are all going to be 3D printing in the STL. You don't have to 3D print in the STL, but let's assume that you all are. If every person is doing a print that takes like 2 days, and there's 120 of you, and we have 10 3D printers working, that's 10 people, let's say 24 hours. Let's say that for the math. Then 10 people can print per day. So that's almost 2 weeks nonstop of 3D printing. We want to try to not do that. So I'm going to continue scaling this so it fits our box a little better. And I think that's going to be fine. You're definitely going to try to fit this better, but for the sake of an exploratory experiment, we're going to say this is good enough. All right, so we know what units we're in, inches. We know how big this is. Now we need to create a mesh. Now, specifically an STL, triangulated mesh. For 3D printing, that is the file type that the slicing software is like. It's a much more simplified version of the geometry um, in terms of like raw data. And there's two different ways we can do this. The quick way and the preferred way. The quick way of making an STL mesh is we select our object, File, Export Selected. Instead of a Rhino 7, we want to scroll down and we want to say STL. Okay, and now I'm going to call this STL version 1. And I'm going to save it to where I'm saving. I'm just going to save it to my desktop. And export. Tolerance 0.001 is good. And binary versus the ASCII is perfect. All right, file successfully saved. Now, what that looks like, oops, remind me later. I'm going to open this STL. Well, not in Prusa, not yet. Sorry, guys. We'll just do this. Scooch this over, bring this in, import in inches. Okay. So this is the quick and easy way to make a mesh. All right. So essentially, it's just a whole bunch of triangles, lots and lots and lots and lots of triangles. Now, the reason this isn't preferred, was I would say this isn't preferred, is we have no real control over the mesh, over how dense the mesh is, and we want as much control as we can get. So if we do the preferred method, we're going to select the object, we're going to go to Mesh from NURBS object, and we have a handy dandy slider to say how many polygons we want. We want all the polygons or the minimal amount of polygons. Now, what does this really mean? All right, well, let's make some really quick example geometry. Let's make a sphere. Come on. All right, sphere. All right, nice and smooth. If we select the object, mesh from NURBS, let's give it all the polygons. And just move that off to the side. Select the object again. Oops, not move, sorry. Mesh from NURBS. Give it the least amount. Right, and then mesh, NURBS. Let's give it right in the middle. Okay. And then let's maximize this again, sorry. We'll go to View, Rendered. And let's actually now what we can see, this is our original NURBS. This is the mesh with all the polygons. So this visually is as smooth as NURBS. The one with the fewest polygons is extremely faceted. That's the difference. there could be a reason to have this sort of visual, but what we want is control. All right, and what we want is to be able to control what that polygonal mesh looks like and how that then affects the output. All right, and then this is we're kind of in the middle of the road where you can't really tell. Okay, now this is why the make the mesh yourself versus the export is the preferred method. All right, so what we're going to do is we're going to take this mesh from NURBS object. We'll give it right in the middle. And if you want to say preview, it kind of gives an idea of what the mesh would look like. And we'll say OK. All right, we're going to take this mesh, move it off to the side. Right, and then if we compare the two, visually, this has a lot more than this does, but this has, I think, plenty to describe the complex curvature of the shape itself. Okay, and whenever we go to export this, File, Export Selected, STL, and we'll call this STL version 2. This is less than half of the other one. Okay, so we have successfully modeled our geometry. It was a closed poly surface. We made our mesh, and we've exported that mesh. Now we are ready to 3D print, actual 3D print. The method of printing, the universals, the principles are universal. They apply to whatever software you may be using, or if you are giving this to somebody else's software that they could be using. The principles are all the same. The specific navigations, the specific workflows is very software specific. So what I'm going to show you is Prusa Slicer, which is what we use in the STL. If you are, a little plug, if you are in the market for a 3D printer, the Prusa MK3Ss are fantastic machines. If you get one, I suggest the assemble your own kit, just so you get a much deeper understanding of the inner workings. Okay. So this is a software that you would be using in the STL. And if you've done your 3D printing tutorial, you kind of already know what this looks like. So what we're going to do is we're going to come up to File, Import STL, and we're going to say STL version 2. Okay, now this came in super tiny. All right, there's a reason for that. Prusa is a European company. They are actually coming out of the Czech Republic. And they have a mild disdain for imperial units. In previous versions of the Prusa slicing software, they're what they called inches, they called barbarian units. So we modeled in inches, but one of the main issues with STL files is that they are inherently unitless. It could be like one of something, 1 millimeter, 1 inch, 1 foot, 1 mile, 1 light year. The STL doesn't really know, and the software doesn't really know. So the software made an assumption, and it was the wrong assumption, but that's okay. What we're going to do with this geometry selected, We're going to come over to the scale factor. And we're not going to willy-nilly scale it up. We're going to say scale factor 2540. Enter. This is now the millimeter equivalent to the inch size. Okay. Now, let's see. The name of the game up for this series of videos has been the integration of process into the geometry. All right, now we talked about the necessity for closed poly surfaces, how to go about keeping a closed poly surface, analyzing for closed poly surface, creating closed poly surface, exporting the mesh, and all that. All right, now what we have to think about is how the 3D printer wants to print this. Okay, now a very slight digression. These machines, and these being CNC machines in general, 3D printers, laser cutters, CNC, milling machines, subtractive methods. They have a whole bunch of ability. They have little on practically zero intelligence. The intelligence, what actually makes the process work, is coming from us, the operator, the people, in this specific instance, setting up the 3D print. So what we have to do is we have to start playing around with these settings, specifically supports and infill, to create the potentiality for a successful 3D print. Now, it's much, much easier than what you think. The biggest issue is that you cannot 3D print in open, unsupported space. Now, what do we call open, unsupported space? Essentially, like this part of the geometry, this part of the geometry. If you try to extrude, so the producers are FDM extrusion-based 3D printers. If you try to extrude in midair, there's nothing for it to latch onto, so it just prints spaghetti. Now, this is spaghetti that doesn't taste very good, and spaghetti that you're paying for. Now, most people don't want to pay for something that they can't use. So most of the time, when somebody says, or like the RPC says, that this won't 3D print, what we're really saying is that it won't 3D print in a usable method for that you will be able to act, for lack of a better phrase, to use. So what we want to do is we need to create scaffolding supports to support these areas when it gets to that point. Now, it's as easy as going from supports. Instead of none, we're going to say everywhere. Yes. And we're going to say slice now. All right, so the orange is is the object that we want to 3D print. The greens are the support material. Now, if we come over here to this fun little slider, we can bring this down. And so at layer 194, this is what we would be outputting. All right, and then 195, 196, and it just builds and builds and builds and builds. All right, so like this part right here was actually, if the supports weren't there, would be 3D printing in midair, and that would not be successful. All right, now with these settings, this takes, according to this, 5 hours and 15 minutes. which for STL pricing, it's $1 for every half hour. All right, so that's $10 plus 15, $11. $11 to print this. Now, we could say that $11 is too much. We could. One way to make it cheaper is to drop down the infill. So we can go from, let's say, from 20%, let's say 10%. All right, now things disappeared. So what we're going to have to do, we'll come back over to the editor view, is whenever we make a change, we have to reslice it, reslice the geometry. All right, so we went down to 4 hours and 44 minutes. So that would be, that's $8, 9, that's 10. All right. All right, now, this object, is only taking up part of the space. Now, if you wanted to, and there would be good arguments for this, you can actually print multiple objects in one go. So I could select this and say copy, paste, paste, paste. All right, so there's 4 of the same thing. I'm just going to move and move and move. So if I wanted to, I could print 4 of these in one go. Slice. And that would take 18 hours and 39 minutes. Now, the 3D printers in the STL, they do run when we are not open. So strategy comes into play here. You and a couple of friends could get together and say, hey, let's print all of ours together, and then start it at the end of the day, and that just goes overnight, and you can pick it up the next morning. That's a great way to maximize your throughput, utilizing as many hours of the 24-hour day to get as much done as possible. Okay. Definitely not saying you have to do that, but if you wanted to, that would be a great way to do it. All right. So we would then export the G code, put it into the machine, and 3D print the thing. It's that simple. The geometry that we have, or that I created, one of the issues specifically is orientation. If this had a flat side to it, like a significant flat side to it, we probably want that flat side down on the bed. But, okay. 3D printing as a tool, it's a lot of it is skill based. We will say that. The more that you use it, the better you get at it, the more you can make determinations about what is a way of doing it, what is a better way of doing it. Now, Jeff, myself, and Max, our current co-op here in the RPC, are definitely here to help you. So if you have questions about how to set up like this part of things, then by all means, we are definitely here to help. So that's it. With that, we are ready to 3D print, and you are ready to 3D print. So we're going to sign off there, and that we will see you in the next one. Cheers.